So I had gotten a few messages regarding question 3.3, particularly why was it removed and can it be solved? So I thought I'd make a video going through it. So question 3.3 reads, calculate the time at which the two balls will move at the same speed. So at first glance, the question doesn't seem that problematic, right? Let's try it. So most learners would do the following. They would say, okay, if it's traveling at the same speed, I'm going to say that the velocity or the final velocity of A is going to equal the final velocity of B. They would then substitute. They would say Vi plus A delta T is equal to Vi plus A delta T. Now, assuming they've chosen up as positive, you could then say 5 minus 9,8 delta T is going to equal 8 minus 9,8 delta T. However, the problem then is that the minus 9,8 delta T cancels and you're left with 5 equals 8, which is not true. So what's wrong with this? So doing this calculation gives us an important piece of information that we must interpret. Because they are not equal, and because this clearly does not work, it means that A and B are not going to be traveling in the same direction when they have the same speed. Because remember, A goes up, it stops, and then it goes down. B is just traveling upward. So that's A and that's B. Because this does not work, it means that A must be somewhere here in this section. A must be traveling downward and B must be traveling upward. So I'm going to show you how we can solve that. So what we could do is we could square both sides to cancel the negatives. So we could say that VF for A squared is going to equal VF for B squared. Now we just need to substitute what we had. So 5 minus 9,8 delta T. So 5 minus 9,8 delta T, and we are squaring that, is equal to 8 minus 9,8 delta T, and we are squaring that. And the reason why we are squaring it is because if we are saying that the velocities are in opposite directions, squaring it will make them both positive. So you then expand this, right? And you expand it, you get 25 minus 98 delta T plus 96.04 delta T squared is equal to 64 minus 156.8 delta T and plus 96.04 delta T squared. So that would cancel with that. And then you simplify. You're going to have 58.8 delta T is going to equal 39. And then you divide and you get delta T is equal to 0.663 seconds. So this is an answer, right? And if you substitute the 0.663 seconds into VF and V for A and B, you'll get the same value or the same magnitude of the velocity, but just in opposite directions. Another way you could solve it, okay, is instead of squaring it, you say that because the answers were not the same here, it means that A must be going downward. A must be traveling down, and A and B must be moving up. So we can account for that by saying minus VF of A is going to equal VF for B. Then you're going to say minus 5 minus 9.8 delta t is going to equal 8 minus 9.8 delta t. You then simplify, you get minus 5 plus 9.8 delta t is equal to 8 minus 9.8 delta t. Now the 9.8 are not going to cancel. The 9.8 delta t isn't going to cancel. So on this side, you are going to have 19.6 delta t is equal to 13. That means delta t is equal to, divide both sides by 19.6, you get 0.663 seconds. So the same answer. And the fourth way you could solve this, the final way, is if you plot it on a graph. So what I'm going to do is I'm going to plot a speed versus time graph. So speed and time. So A starts at 5 and B starts at 8. And it goes down like so. And remember, the gradient is 9, well, in this case, it's going to be minus 9.8. So the gradient is minus 9.8. And for ball B, it's going to experience the same gravity, same acceleration, so it's going to be minus 9.8 as well. So the lines are going to be parallel. So the fact that these lines are parallel tells us that A is not going to have the same speed as B on its way up. Now what happens? Let's focus on A. So this is for A and that's for B. Now, because this is a speed graph and speed versus time and speed is a scalar quantity, it will not go below this x-axis. Rather, it will go up this way. Now, the gradient of this line is going to be 9.8. The gradient of this line is minus 9.8. And the gradient for this line as well is minus 9.8. So what we're looking for is this point right here. We're looking for that time interval there. So the way you can solve this is, if you look at this line will have an equation of y equals minus 9.8x plus 5. This line will have an equation of y is equal to minus 9.8x plus 8. Now, we need this line to get the equation of this line. So to work out the equation, we need to work out what this is. So to work out this point, we're going to say y is equal to minus 9.8x plus 5. Since it is the x-intercept, you make y 0. So 0 is equal to minus 9.8x plus 5. You get x is equal to 0.51. So this is 0.51. In other words, after 0.51 seconds, A reaches maximum height, or it stops at its max height. Now that we know that point, and that point is the same for this other line, we can then work out the equation. We can say, for that line, y is equal to 9.8x plus c. This coordinate is 0.51 and 0. So 0 is equal to 9.8 into 0.51 plus c. And then you get c is equal to minus 5. So the equation of this line is y is equal to 9.8x minus 5. So we are solving for the point of intersection between, let's use a different color here, this pink line and this purple line. So to get the point of intersection, you equate the functions. So you're going to simply say that minus 9.8x plus 8 is equal to 9.8x minus 5. Now you can simplify. You'll get 19.6x is equal to 13. Notice that this is the same as what we had here. So then you get x is equal to 0.663 seconds. And yes, I think it is solvable. If you have any ideas as to why the question was removed, do let me know in the comment section below. If you have other ways or other options, or other solutions, do let me know as well in the comment section below. Thanks so much for watching.